Well, here we are today to talk about multiplicative relationships. This is Miss Elkins. Welcome to my YouTube channel. And when we say multiplicative is not just multiplying. It does include division, but there's no such thing as dividative relationships, or no one says that. So just keep in mind that a multiplicative relationship could also include division. Most of ours will be multiplication, but they could include division. So let's look at an example here. An event planner is organizing the seating chart at a wedding reception. She has drawn the diagram below. You can see the circles are tables and the little squares are chairs. And you can see there's approximately, let's see, 1, 2, 3, 4, 5, 6, 7, 8 chairs at each table. Number 1 says, describe the ratio of tables to chairs at the wedding reception. We could describe that exactly the way it asks us to and say there is 1 table for every 8 chairs. That would be the relationship. Guys, if you're not taking notes, please stop the video right now and get a piece of paper and take some notes. Number 2 says, if there was a change and the wedding now needed 6 tables, then how many chairs would be set up? Well, if there's 8 chairs at every table, we could multiply 6 times 8 to find out you would need 48 chairs if you had 6 tables. That's what we consider a multiplicative relationship. You multiply the number of tables times the number of chairs to find out how many you need. Let's dig a little deeper into multiplicative relationships. These are some important terms that you should know. First of all, a multiplicative relationship can be described by an equation or the equation, and these are just variables that we place in place of numbers that we don't know. Y equals AX. Also, you might see Y equals KX. Those two things are interchangeable, but some people use K, some people use A. We're going to use A. The first thing you need to know is that Y represents the output. If you did input-output tables last year, maybe you remember that. It's also what we just learned earlier is Y is also the dependent. If there are no tables, then you don't need any chairs to go with the tables, right? X represents the input, also known as the independent part. And A represents what we could say is the multiplier. But when you get into algebra, they're not going to call it the multiplier. They're going to call it the constant. Okay, because that multiplier won't change. The A value always has to be constant in order to be considered a multiplicative relationship. So if the multiplier changes, then you don't have a multiplicative relationship. Doesn't mean it's not an algebraic relationship, it's just not multiplicative. So let's look at how that works with the equation. Use the tables below to determine the equation in the form Y equals AX. So we look at the table, we look at the X values, and we look at the Y values, and we figure out what is happening to the X value to make it become the Y value. Here we have X is 2 and Y is 8. Then X is 3 and Y is 12. Hopefully you can see that what's happening here is we're multiplying the X times 4. 2 times 4 equals 8. 3 times 4 equals 12. 4 times 4 equals 16. So the multiplier here, the A, if you will, is 4. So the y and the x stay the same, and we write that equation like this. Y equals 4x. The 4 goes in place of the a because the 4 is the multiplier. That's the way we write it. We don't write 4 times x, 4 dot x, 4 parentheses x. We simply write 4x, which means 4 multiplied times x. And there's the equation that goes with that table. It's pretty easy, right? Let's look at the second table. The process to get from 0 to 0, well, could be adding 0, right? But let's move on. The process from get from 1 to 6 could be plus 5, or it could be times 6, since we're doing multiplicative relationships. Let's look at this one. To get from 2 to 12, oh yeah, the multiplier here is times 6. And anytime you multiply 0 times a number, you're going to get 0. So the process here in each one of these is times 6. If ever you can't figure out what the multiplier is, you can always take your y value and divide it by your x. So I know that 6 divided by 1 equals 6. I know that 12 divided by 2 equals 6. I know that 18 divided by 6 equals 3. I'm sorry, I said that wrong. 18 divided by 3 equals 6. That's what I meant to say. Okay, so the multiplier is 6. We write the same equation every time. Y equals 6x. There's a multiplicative relationship for you in the form of multiplying times 6. It won't always be that easy. So you do need to remember that you can divide the y by the x to find that multiplier if it's not obvious. Okay, let's look at some examples that are given to us on this paper. One thing you need to know, and basically this is every algebraic relationship, it can be represented by an equation, a graph, a table, and a word description. All those 4 things are just the main points of this whole unit. You need to recognize an equation, a graph, a table, and a description for an algebraic relationship. So let's look at this one. They gave us the description. The cost of an ice cream cone is $1.50. Now we have to relate that to the table and to the graph and write an equation for it. Well, one thing that I find helpful in this particular case is they told us that the number of ice cream cones is the independent variable, the x. And they also told us that the total cost is the dependent variable, also known as the y. So my equation is easy. Every time I buy an ice cream cone, it costs me $1.50. So y, the total cost, is equal to $1.50 times x, the number of cones that you buy. There's your equation. Super easy, right? Okay, now we have to graph that situation. So let's look at the graph. Oh, it's all filled in nicely with numbers and costs. So this should be easy to graph. If you buy 1 ice cream cone, it'll cost you $1.50. If you buy 2 ice cream cones, it'll cost you $3. If you buy 3 ice cream cones, it'll cost you $4.50. And guess what? That graph is just going to keep moving on up in a straight line. And if you wanted to make it into a line, you could draw a straight line starting at the point 0, 0 all the way up to see that every time you buy an ice cream cone, that y value will go up by $1.50. And if you buy 0 ice cream cones, it will cost you $0. Okay, so that's what my graph looks like. You don't have to draw the line. The dots are fine because you're not going to buy half of an ice cream cone, are you? Anyway, now let's fill in the table with the numbers that we know. You must put something in the table to describe the things that are there. X and Y is not acceptable, even though we know that X is the first column and Y is the second column. You need a word description in that table. So for my word description, I'm going to put cones, because we're buying ice cream cones, and I know that X is the number of ice cream cones. And for my word description for Y, I'm going to put cost, because we know that the cost is the Y values. So, and I can pick anything I want to put right here as the number of cones I'm buying, but I'm just going to decide to put 0, 1, 2, 3, 4. You could put 0, 10, 20, 30, 40. You could put 200, 300, 400, but I'm just going to use easy numbers, 0 through 4. If I buy 0 ice cream cones, that will cost me $0. If I buy 1 ice cream cone, that will cost me $1.50. If I buy 2 ice cream cones, that will cost me $3. And then we just fill in the table with the amounts that go along. Okay? You don't necessarily have to write this down, but you do need to watch so you know how it works. Let's look at another example. Again, we have 4 representations of the same thing. In this case, they gave us the equation instead of the description. So we have an equation here. So we need to come up with a description that could match that. The equation they gave us was y equals 7x. Y something equals 7 times something else. So I've already come up with what I think is a pretty good description. Let's say that a movie ticket costs $7. There you go. $7. Every time you buy a ticket, it's going to cost you $7. Now, we have to figure out what's Y and what's X. Well, X has to be the number of tickets you're buying, because you're multiplying 7 times the number of tickets. So I'm going to label the bottom of my graph tickets. That means the other side has to be total cost, right? And there's no numbers on my graph, so I'm going to have to figure out what numbers to put. I'm just going to start with 1 and work my way up. 2, 3, 4, 5, 6, 7, 8, 9, 10 on the bottom. But on the side, on the Y values, I'm going to go up by 7s just because that'll make it easier to graph. So I'll do 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. And then I'm going to graph that. So if I buy 1 ticket, oops, I didn't mean to do that. If I buy 1 ticket, it costs me $7. If I buy 2 tickets, $14. 3 tickets, $21. 4 tickets, $28. And as you can see, the graph's going to keep going in a straight line because every ticket costs the same as the other tickets. So, also notice that if you purchase 0 tickets, it will cost you $0. This also would go through the origin, as you can see. And I can't draw a straight line, but you get the idea. Because if you buy 0 tickets, it's going to cost $0. Every multiplicative relationship will go through the point 0, 0. All right? Now we got to fill in our table. There's 2 things we have here. The X values are the number of tickets. It's still on the shape tool. All right, so the number of tickets, and the Y values are the total cost. So I'm going to do the same thing I did before. I'm going to do 0, 1, 2, 3, and 4. I could pick any numbers I want for the number of tickets I'm buying. but I'm just going to make it easy. If I buy 0 tickets, it costs $0. That will always be on your multiplicative chart if you fill it out completely. The table will always be able to have the 0.00. If it doesn't, then it's not multiplicative. It may not show it on there, but if it's possible to put it on there and still make it make sense, then it's multiplicative. And so if I buy 1 ticket, it costs $7. If I buy 2 tickets, it costs $14. If I buy 3 tickets, it costs $21, and 4 tickets is $28. So that takes care of, that takes care of that representation. And again, there's 4 different representations that all give me the same information. A cost of a movie ticket is $7. Y equals 7x. The table goes up by 7s. The graph goes up by 7s. So that tells you they're all the same. Okay, now we got one last example to do. This example also, we have an equation, a graph, a table, and a description, all on the same algebraic representation or relationship. So if you look closely, the table is what they've given us. And if you look at the bottom of the table, it's time in hours and miles traveled. So what we need to figure out is what's that relationship. If I look here, if I'm traveling for 1 hour, it looks like I'm going 25 miles per hour. If I'm going for 2 hours, it looks like 50 miles traveled. 3 hours would be 75 miles traveled. So it looks like something is happening at a rate of 25 miles per hour. So let's write a description that goes with that one. I've got a good one. A biker is riding at a constant speed of 25 miles per hour. Probably should say moped, because I think it'd be pretty hard to ride a bicycle at a constant speed. Maybe you could do it, maybe you couldn't. So my equation, my multiplier is 25. My equation looks like this. Y equals 25x. And now all we have to do is fill in the table. And in the table, we have hours as our independent variable and miles as our dependent variable. No hours, no miles. And I'm just going to put 0 on my chart or on my table to represent if there's 0 hours, it's 0 miles. If that biker travels for 1 hour, they'll go 25 miles. 2 hours, 50 miles. That looks more like a 6. 2 hours, 50 miles. 3 hours, 75 miles. And 4 hours, they'll go 100 miles. I doubt a bicycle could go that far in just 4 hours. But maybe some people are that good. Okay, so that's the 4 representations and how to write an equation to go with a multiplicative relationship. Later on, we'll talk about additive relationships. I do want to summarize this lesson. So please copy this down. Even if you didn't have the notes to write on, I need you to copy this down. Here we go. All multiplicative relationships, can't spell, relationships are written y equals ax or y equals kx. A or k is the multiplier, and this is even the most important thing of all, so I'm going to put a big asterisk beside it. All graphs of multiplicative relationships will go through or start at the origin. That's very important, so make sure you copy that down. All multiplicative relationships are written y equals ax or y equals kx, where a or k is the multiplier. And very, 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 very important, all graphs of multiplicative relationships will go through or start at the origin. Super important. Hope you're doing well. Hope I see you soon. Miss Elkins out.